friends, welcome back to our channel Education Hub. As usual, we come here along with another computer science related lecture. Before starting, please subscribe our channel, press the thumb to like, and obviously don't forget to press the bell button for your future lecture notification. Let's start today's lecture. Introduction to Discrete Mathematics. Discrete mathematics is a thing without which we cannot move anything in computer science. Before starting, once again I am telling, please subscribe our channel, like our videos, share our videos, and give your precious comments. What is discrete mathematics? What is not. Discrete means it is not continuous, consisting of discrete, unconnected element, continuously infinite. Definition of discrete mathematics is a collection of mathematical topics that examine and use finite and countability infinite mathematical objects. That is, it is not continuous, some discrete elements is there, but making some assumption, predictions, we have to do it. First one, in discrete mathematics, we should learn set. Set this to explore various similarities, some families. We can explain it by using Venn diagrams. In CS, to learn to represent computer memory, operations of programs, we use our set theory. You can follow the screen. Always I prefer in our education society hub to give you time to more and more learning purposes. Let's follow the screen. Set theory is also necessary for computer science to get more and more notifications also. It is the definition of set. The definition is well defined as collection of discrete objects, members or elements, parts of collection. The roster methods is also called the listing elements in a enclosed in a brace. You can able to see here the set of vowels, primary colors. These are the examples of set. The membership examples: A belong to a set of vowels. Similar, A is a subset of vowels. How it is written? You can follow it from the screen. J does not belong to the set. Here also you can follow, but our channel's this description is not able to show you the properly. From the next lesson, you will not face this type of problem. See here, the sets are given. The sets is the builder methods. Here the A equal to AX. See here the set builders methods is also defined. A equal to X. X is a subset of S. So P of X is the total set. Now this way we can define it. You can follow the screen. There also you can able to get the examples. So what is set? The specific symbols of set theories is defined here, where N is the natural number set, Z is the set of integers, Z star positive integers, Z star is a set of non-zero integers also, Z plus positive integer, Z star E set of even integer, Q. I think I don't have to say also, yes, because you can follow the screen and there also you can able to get. All the notification, all the symbols which we have to use, what it denotes in set theory, you can able to get from the screen. Now here the what is subset? If a set or a set it is belong to another set, then that set is known as the subset of that set. See here X is the subset of Y, then we can write in this way. The screen will tell you how to write. And if it is not subset, then you can set it that. Just set, cross it from the beginning. Now the example, X is that. Now Y is A, that is A, E, I, O, U is X, and Y is just A, I, U, and Z is B, C, D, E, F, G. So that way you can write down. So superset is that X are the set of sets. See here, the symbols is showing you. Symbol you can get from the screen. It's by defined. If I tell you that also not be make you understand. Now the proper subset that must be belong and does not exist. See here, which one is proper subset? Subset equal to the symbols is given here. So here from you can able to get what is superset and power set. The set equality, if that is X is subset of Y and Y is subset and equal to Y and Y is subset and equal to X. For example, X 1 2 3 2 3 1. So X is blue, red, yellow, or it's a primary color. Y is a C is a primary color. Therefore, we can able to say that X equal to Y. Empty null set whose value doesn't here. In our we can define this as a null sign. For example, suppose you don't have passport and they ask you about the passport number, then that will be null set or empty set. Please follow along with my conversation also. You please follow lectures also. You please follow the screen. Here the denote the symbols you can able to get. Now the thing is that the symbols I cannot explain by using our lectures. So you have to follow it from the screen or board work. Many lectures is on boards also. This lectures is not. So please follow. I think you can able to get right now what is set, why should we learn it, and some symbols and notifications of set. Now here the cardinality of set. If S is a finite set with n discrete element where n is greater than equal to 0, then mod of S is equal to n, where the cardinality or the number of element S is n. See here, if P equal to set of red, blue, yellow, then the cardinality is 3. So we can say the number of elements. Singleton whose elements is only 1. That is called singleton. I again repeat the power set. There I doesn't explain only because of this reason. For any set of x, power set of x is written as P of x is the set of all subset x. Suppose here the examples is there. X is red, blue and yellow. The power set is equal to null, red. That means all the possibilities you can say. Red, blue, yellow, red, blue, red, yellow, blue, red, yellow, all. And the universal set, that is arbitrarily chosen. All the values are there. Universal set is all sets belongs to the universal set, containing all of the sets, you can say. So the symbols you can able to get from the screen also. Please follow the screen. I think right now it is clear to you. In between this, I once again tell you that the set representation techniques is also a Venn diagram is one of them. Venn diagram, that is the pictorial view you can able to see from the screen. It is where U is the universal set and X is the set. See here. The abstract visualization of universal set is the rectangle, and where all the sets are subset of universal set. Obviously, we all are elements of universal. That's why here the union of sets means combination of two. Suppose X is a set, Y is a set. So X union Y tell you X, all the values belongs to X as well as Y. Intersection, just common part. You can able to see the shaded proportion of the figure, which must contain in X as well as in Y. They will be disjoint set is they both are disjoint to each other, so no common element will be there. So if the intersection we have to take, then it will be null, because there is no any common element is there. Now the difference, that is whose value is belong to set A not in B, that will be the difference. That means the value should be in X not in Y. Here the complement, that means what is in universal set but not in X set, that is X complement set. See here the universe is given A, B, C, D, E, F and X is C, D, E, F. So then X complement should be A, B, that is not in X. In B universal but not in X. So I think you can able to get what is the set and the details. I think you can able to get it. So here the complement of set, that means it should be inside the universal set but not in that set. So you can able to get from the screen also. Every time I give you some time to read it, only because reading the slides will be more beneficial for you to get to understand the symbols also, because set is very much easier, but the symbols you have to remember. See here, the sets is given, the examples is given. The Venn diagram of set X minus Z union Y. Y union Z, the values become, then from X it is minus, that means value is in X but not in Y, not in Z. That way you can represent here the order pair or the Cartesian product, both will be explained here. The X and Y are the set. If X belongs to X and Y belongs to capital Y, then the order pair will be written in XY. Order pair of element is very important. It is not necessarily equal to YX. Cartesian products is given. Cartesian order pair already I discussed, and Cartesian product, all the symbols will be notified. Just multiply it to each other and the representation will be there. Now the all formulas of set properties is given here. The independence, absorptive, commutativity, distributivity, complement, involution, identity, De Morgan's law, our distributivity and complements, all are explained here. Please follow the screen. Because of the symbol I cannot able to tell you. I can tell you everything, but it will be not be too much understandable for you. So please follow the screen. Now computer representation of set, what we read already, why should we learn? In computer science, what is the necessity of the our set theorem? You can able to get from this area, that is all the sets are computed in an array or unsorted list. For a linked list, for bitmaps, for implementation as file, everywhere we need it. All the representations technique of bitmaps or bit string you can able to understand from the set theorem. So the set theory is such one which is very much necessary for computer. It's more applications, just one by one point wise I will describe it right now. Bitmap, file, operations of all, that is from intersection, union, elements, difference, complements, power set, all you can able to get from the set operations. This one by one all the operations is already described. Multi-set, order set, this is also special sets in computer science. Now the mathematical logic we have to understand. Any sentence, any word, that is P is 2 is an even number, 7 is an odd number or even number, this type of one sentence which may be true, may be false. If I tell 7 is an even number, that is a false statement. These are represented as proposition. The proposition may be true, may be false, may be both or may not be. The true value will be represented as T. Negation, that is the complement values you can able to get. So if the negation, that means if it is true, then in negation you will get false. If it is false, in negation you will get true. You can able to get it from the screen also. The truth table is also given here, but unfortunately for our slide designing hampered your vision right now. I will remember that from the next our lectures you cannot able to face such problem. Please follow the screen. Every time I ask you to follow the screen only because in every time it is necessary to read for coding or any other purposes. For discrete mathematics, it is beneficial for the symbols. Now one thing more I have to tell you, this is the conjunction of mathematical logic. Conjunction means let A and B two set. Conjunction of P and Q will be, which will be in P as well as Q. That is, I can able to say what we in set theory we read it as intersection, that is nothing but conjunction. Disjunction is nothing but union, which may be in P or may be in Q. Implication means, implication you have to understand that let P and Q two statement, then if P then Q. If P is for conditions is satisfied, then obviously Q it will be. This is a hypothesis. P is called a hypothesis, then Q is also called the conclusion of this hypothesis. Here I am explaining, but in slides you will get the proper notification or the proper definitions. So what is disjunction, what is conjunction, what is implication? I think it is right now clear to you. Now the implication, let P, today is Sunday and Q is telling I will wash the car. Then P implies Q means today is Sunday, that's why it implies I wash the car. This is. And in converse we can say Q implication P, that is also possible in the condition if it is satisfied. Now by implication means both will implies to each other. This is by complication. If P, then only if Q, and if Q, then if and only if P. That type of conditions will be there. Now the precedence of logical converse will be given here. The second highest, highest, third highest, fourth highest, fifth highest. That way the precedence of logical converse is given here. Now the tautology and contradiction. Tautology, that is always true. It cannot be possible to be false, and contradiction, it is always false. Never it be possible to true. Follow the screen, you can able to get it properly also. Now the logically implies, logically equivalent, this too you have to understand. Logically equivalent means a statement formula A is said to be logically imply a set of formula B if the statement formula A implies B is a tautology. If A logically implies B, then we can say A logically implies, symbolically A implies B. That means when it is tautology, then it is logically implies, and logically equivalent means both implies, both side implies, imply sign will be tautology. That means always it will be equality. Please follow the screen, you can able to get it very clearly also. Here in this lecture I told you only about the set and the logic, the proposition part. Next lecture it will be gives you the more and more details of our discrete mathematics. You know, discrete mathematics you cannot able to get in a single lecture, so, but as much as possible you can able to understand, it is given here. Now here the formulas of logical equivalence is showing here. It I will not read it. I will try to tell you that please follow the screen to understand it. It will be better. I give you enough time to read our formulas because it is all the fundamental equivalences there. Now interface of sub-institutions is given here. Please follow the screen here. The substitution and equivalence statement, replacing logically variable and tautology and using rule of interface is showing here. I give you here also the time to read the slides as because it will be beneficial to better understanding. So the substitution and equivalence statement, replacing logic value variable in a tautology using rule of interface. What is interface? It is explained here. The more logical equivalence is showing here also. You can able to get it from here. Here the biconditional, negation, implication and transitivity of biconditional is showing. In all the lectures, here also the logical equivalence rules of interface related or to the theorem, it is given here. This theorem you can able to follow also in several lessons, several lectures. I will explain it also in our next lecture. Just I am showing it here. You can able to prove it also, but there I will explain it one by one in our next lecture. Now the quantifier and the first order logic is also given here, predicate and propositional function. The predicate or propositional function is if let x be a variable and d to be a set, then p of x is a sentence. Px is called predicate or propositional function. Moreover, D is called the domain or universe of discourse, is called also free variable. Now, D is called the domain or universe of discourse and it is called the free variable. So what is free variable? You have to understand the universal quantifier is that where the predicates, let Px is a predicate and let D to the domain of discourse. Then the universal quantifier px is the statement we can able to say. You can follow the screen. And here p of x in the symbol is just opposite of v or opposite of a, you can say, it will be better. See, the universal quantifier is showing here. Universal quantifier is very much necessary to our DBMS lecture also. You can DBMS where the calculus we will do, there also you will get this notification. There exists an universal quantifier. I give you the time to read it. Now we are about to the end of this lecture. Before ending, I will tell you the more logics, and after that, one by one, it will be explained in our next lecture. So at the end, it is not only end. Sometimes also something also I have to explain. Let's explain it. In between this, I'm showing you the just our appeal that if you like this video, then obviously please try to like it. Now here the negation or notification of De Morgan's is also explained. I am not telling you anything regarding this as because I will explain it once more in our next lesson, and here I am showing you only this. Here the definitions of Boolean algebra. In our Boolean algebras lecture you will able to get it also. Just I am showing it here. What is identity, complements, continuity and distributivity? It is explained here. Already we have our Boolean algebra lectures. From there you can get it elaboration. Here the Boolean algebra, two elements of Boolean algebra is given here, class product, dot product and the negation product. That means conjunction, disjunction, all are showing here. If it is plus product, then if it is 0, 1, then 0 and 1, 1, 1. You can able to get it also. This is the two element of Boolean algebra. Here you can able to get two elements Boolean algebras lecture representation. So please follow the screen. Here the duality and fundamental of Boolean algebra properties is also given. Here also I am asking you to follow the screen please, because of all the formulas of Boolean algebra's properties is given. I am explaining you the duality. Duality is the Boolean algebra's theorem. Show you the both way. the dual of the, that means both way it will be applicable. I think you can able to get it from here. Unless I give you enough time to read it. Here the logics and CS I'm explaining here. Here the logics of basic ALU, that is also follow the Boolean algebra. The logic of crucial if, that is and or not, all are given here. Logics basic of ALU, the crucial if statement, and or not, implication, implementation of quantifier, that is looping, and database query language, that is differential relational algebra, relational calculus or SQL. Everywhere of the CS we need the logics of, that is all propositions. I already told you it will be implemented there. These all are necessary. You can follow the screen also. Here also you can able to get. So at the end of the lecture you can able to once more I have to tell you, please subscribe our channel and like and share the videos, and after subscribing don't forget to press the bell button to get the notification of our future all lectures. Thank you for listening this lecture. I think it will be beneficial for you, it will be helpful for you. Give more comments.